much faster.
What could the results of this speed of buildup of CO2 be?
We know that as CO2 builds up, the temperature goes up.
Right.
The temperature lags. It takes a while for the system to come along, right? You put some heat lamps on a glass of ice, and it's going to be ice even though you're putting heat into it for a while, and the temperature's still going to be freezing,
Latent
right?
heat of fusion.
Yeah, exactly.
Right.
And we've got these huge thermal masses, the oceans, which hold thousands, millions of times the heat that the atmosphere does. So as well, the atmosphere isn't warming up that much. Yeah, it's all going into the ocean.
Okay. Okay.
And so the fact that we're seeing the rise in temperature that we do in the atmosphere means that we're adding tons and tons of heat. We're going to see a rise in temperature as a result. And if it happened over 1,000 years, we'd see a rise. And if it happens over 2 years, we're going to see a rapid rise. Or we're going to see a rise. It's just a question of what the dynamics are along the way. What we understand now is that the climate system is what we call modal. It likes to be in one place or another. It doesn't like to be in between. So it's hanging out in one place and it's sort of getting pushed and pushed and pushed and pushed, and then it goes, okay, flip, and it goes to another place pretty rapidly. So we are pushing the system very, very strongly right now with carbon dioxide, not to mention other activities, but that's sort of the headline.
Yeah.
And we have some ideas about the implications in the near term, but the details are things that we don't know because it's a very complex system. We've never observed the Earth being pushed through this system before these changes before, so we don't know we don't know the details.
Right.
We do know some of the things that can happen. Now, you were mentioning circulation. That's one of them. The oceans circulate, turn the water over. They have a big what they call a conveyor belt that turns over about every 1,000 years. And the basic story is that in the North Atlantic, water gets cold enough and salty enough to sink. It sinks down to the bottom of the North Atlantic, and it flows south through the Atlantic and out into the Indian and Pacific Oceans, and it comes up everywhere along the way, and then it returns along the surface, finally concentrated in the Gulf Stream, returning as hot water to the North Atlantic.
Almost recycling it.
It is just going around in a big cycle, and this is very well known. We can track the water. It's all dialed in, but it all depends on the water that gets to the North Atlantic being cold enough and salty enough to sink. Okay, two things make water dense: being colder and being saltier.
Right.
Okay. As the Gulf Stream heads north, fresh water evaporates from it, and it becomes saltier. Okay. As it gets to the North Atlantic, it loses heat, which is why Europe is warm, by the way, and it gets cold enough, so it becomes cold and salty, and it sinks. If we change either of those two things, then that circulation stops. The thing that we're most at risk from, as far as we can tell, is melting ice from Greenland, making the North Atlantic fresher. In other words, not letting that water get salty enough so it doesn't sink.
Okay.
And then the Gulf Stream stops and Europe gets very cold. It's an enormous change. It also has implications for the biology of the ocean because this turnover brings oxygen to the depths. There's all kinds of things that change as a result. We would see a radical change in climate if this happened. The Gulf Stream transports about half of the heat that's transported from the equator to the poles.
Okay.
So half of it's in the atmosphere, half of it's in the Gulf Stream.
Oh, wow.
So it's a radical change. Another thing that's sort of front and center in my mind and in the minds of a lot of folks is that the permafrost regions around the Arctic are deep frozen soils that contain methane, and a lot of methane, because the poles warm up faster than the equator. So, for example, when the last ice age ended, Greenland got 20 degrees centigrade warmer, where the planet got 5 degrees warmer on average. So
due to permafrost methane.
So yes, the poles are getting warmer much faster. We already observe it. There's all sorts of things in the Arctic that are telling us this. loss of towns like Shishmaref, and I mean,
Right.
it goes on, right?
Right.
The polar bears.
Yeah, polar bears, the melting of the Arctic ice, the sea ice, and the risk is that as we warm the Arctic up more than the rest of the planet, that permafrost melts and releases its methane. Methane itself is a greenhouse gas, which is stronger than carbon dioxide, and so it adds to the warming even without us burning anymore, and becomes a sort of a vicious circle, right? The more warm it gets, the more methane we have. The more methane we have, the warmer it gets, the more methane is produced, and we get a runaway situation. That runaway situation would leave us with about 800 parts per million or more in the atmosphere. It's worthwhile to note that the Antarctic ice sheet, the big one, that's worth 300 feet of sea level rise if it were to melt, formed when carbon dioxide levels dropped below 450. So 50 million years ago, we were probably at 1,000 parts per million because of, as far as we know, probably a big volcanic activity, a big volcanic, like the activity that created the North Atlantic Ocean. Okay, so big time.
Yep.
Since then, since 50 million years ago, carbon dioxide levels have been going down because of weathering and the rocks and a few other processes, which happen very slowly but inexorably remove carbon dioxide, until about 33 million years ago, when carbon dioxide got to about 450 parts per million, right? We're coming down from 1,000, we get down to 450, and that's when the Antarctic ice sheet formed. Okay? So if we go back up, okay, it's not going to happen overnight that the Antarctic ice sheet's going away, but if we go over 450 or 500, we can expect that it will go. And that's worth 300 feet of sea level rise.
And what's the impact of life for something like that to happen, that much of a rise?
There's a couple of factors. There's what's the impact on civilization? Obviously,
Chaos.
300 feet of sea level rise is chaos, right?
Yeah.
4 feet of sea level rise, which is actually something that we could well see in a century or more. We could see 10 feet.
Okay.
Is chaos. 10 feet of sea level rise is, I forget the exact numbers. It's several hundred million to I think over 1 billion refugees.
Like Boston, Manhattan type places.
Boston,
all the
Bangladesh,
islands.
Shanghai,
Major population
Beijing,
centers, okay.
Singapore, Florida, Galveston, and the issue is, people say, well, let's go to Katahdin or something, but the point is, if you do happen to live somewhere that's not inundated and still has the ability to provide food and shelter, you're going to be visited by a lot of people who don't. And,
More chaos.
The issue is not, gosh, we flooded some cities. The issue is, the chaos that's going to arise from people looking for a place to, sleep and eat.
Self-sustainability.
Yeah, it's going to be. It'll be a mess.
That is the biggest.
So from a civilization point of view, that's where sea level rise gets us.
That's an immediate. That's
And that's
a more
only with
immediate
10
threat.
feet, let alone the 300
Let
that
alone
could.
300,
Right.
exactly.
Imagine.
So if we make it over 4, 5, 600 in this century, and if the permafrost thing gets away from us and we make it to 800, okay, we'll certainly see 6-10 feet of sea level rise this century, and maybe more. And eventually, are we talking a few hundred or 1,000 years? Who knows? But somewhere in that range, probably, we're looking at 300 feet. There's a more proximal issue that is actually probably going to get us before even the sea level, which is that as carbon dioxide levels in the atmosphere rise, most of that goes into the ocean. Atmospheric carbon dioxide levels have made it from 280 to 380, let's call it. 100 parts per million we've added in the industrial era.
Right.
Okay. The oceans have absorbed about half of the carbon dioxide that we've emitted. So what that means is that if the oceans were not absorbing carbon dioxide, we'd be at 480. That's already melting. I'm just saying that
accelerated.
Yeah, exactly. It's just that over 450, it's melting enough so it'll be gone eventually.
Right.
Right.
Is that number 375 or 500? Let's talk. We don't know.